All right. So let me just share my screen. Can you see my screen? Hello?
Yeah, you can see the screen.
All right, great. Okay, let's get started. All right, so good evening, everyone. Welcome to today's session, Intro to Smart Contract Development with Lumos Lab. Yeah, my name is Kaswini Ojukwu. I'm also coding CAS and all of that. Yeah, I write smart contracts. So, for the purpose of this class, we are going to be writing smart contracts. We learn about the Solidity programming language. So I need to make someone the host because there are some persons that wants to join, but because I'm talking, I won't be able to see them. So I need to make someone the host so that they can see, okay, I think this is coming. Let me just continue this to avoid being distracted. Just give me a moment. Let me make Sarah the host. Make host. All right. All right, Sarah, you're now the host. So if anyone tries to join, you see them and you please admit them. Thank you. Can you guys still see my screen? Oh. Sorry, I'm trying to enable sharing for all so that even if I'm not the host, I'll be able to share. Okay, let's just continue, scratch that. So what is Solidity? Like I said earlier, writing smart contracts on the blockchain, especially the Ethereum blockchain, we make use of a programming language called Solidity. And Solidity is a programming language that runs on all EVM compatible blockchains. Example, Ethereum, Binance, Polygon, Avalanche, Phantom, what's it called? Arbitrum, and many others. So there are so many EVM compatible blockchains. So with Solidity, you write smart contracts that can be deployed on all of these blockchains I've mentioned. And that is why Solidity is a it's a very cool programming language to learn and all of that. So yeah, let's continue. Can you see my screen, please? Let me know if you can. Hello?
Yeah, I can see your screen.
All right. So Solidity is a high-level programming language, high-level object-oriented programming language that is used to write smart contracts on EVM blockchains. So it also supports inheritance, libraries, and sophisticated user types. Solidity is statically typed, which means unlike JavaScript that when you declare a variable, the JavaScript language already knows the type based on the value assigned to it. For instance, if you declare a variable and assign it a value of a number, JavaScript automatically knows that that variable holds a number. And if you assign it a float, JavaScript already knows that that variable is a float. If you assign it a string, it knows that it's a string. But Solidity is not like that. Solidity, you have to manually tell it the type of variable you want to, the type of value you want to assign to the variable. That's why they say it's statically typed. It doesn't automatically know the kind of value it's holding unless you tell it. So while you're declaring your variable, you give it a type, and that's why they say Solidity is statically typed programming language. So Solidity is statically typed. So the data type for each variable must be specified at compile time. So the variables can only accept the data type for which they were designed by the developer and cannot be altered dynamically. This means what this is saying basically is if you declare that a variable is supposed to hold a value of integer, you cannot assign it a value of string. Two people wants to enter. Just give me a moment. Let me admit them. Yeah. So if you give it a value of sorry guys. Okay, yeah. If you give it a value of if you declare that this variable is supposed to hold integer, you can't assign it. All right. Can you guys still hear me?
Yes.
All right. So if, like I was saying, if you declare a variable to be an integer, you cannot assign it a value of string. And if you declare the value to be a string, the variable to be a string, you cannot assign it a value of integer. So let's move to the next slide. Now, all right, let's look at Solidity data types. The difference between Solidity data types, the difference between data types in Solidity and those other programming languages are subtle, but significant enough that many developers find this topic to be confusing. So I keep telling people Solidity is a very simple programming language, very, very simple. I think it's the simplest programming language I've ever seen. It's more simple, it's simpler than JavaScript, yeah. The only difference is just the difference in data type. Unlike JavaScript that has integer, string, float, null, and all of that, Solidity has different data types. Like it has unsigned integers, it has address as a data type, and many other stuff. So we are going to look at this data type. So like other programming languages, Solidity classifies data type into two different types, right? So we have the value type and the reference type. These are the two types of data types Solidity have. So all the data types in Solidity are grouped into two different types, the value types and the reference types. So we are going to look more into that in the next slide. Now, Solidity value types. A value type stores its data directly in the memory it owns. So variables of this type are duplicated whenever they appear in functions or assignments. The value type will maintain an independent copy of any duplicated variables. Therefore, a change in the value type of a duplicated variable will not affect the original variable. So what this is saying in essence is, now, when you declare a variable in Solidity. I will have to escape this presentation to show you guys this stuff in Solidity directly. Can you see my code? Let me know if you can. So this class is more practical than theoretical. If you can see my code, let me know. Can you see my code, please?
Yes, sir, we can see it.
All right.
Yes.
So let me quickly create a new Solidity file so I'll be able to explain this better. Okay, this guy is up. All right. So I'm going to create a new contract here. I'll just call it teaching.so. So let me zoom in so that you guys will be able to see this guy. Teaching.so. All right. I believe this is big enough. So I'm going to just do this. Let's go 0.8.4 and I'll say contract teaching. All right. So I'm going to declare a variable. Let's say I'm going to call it uint, and I'll call it num1. And I'm going to say, I'll just leave it here like this. Now, I'm going to declare a function. Let's just say function use num1. And this is going to be an external function. All right. Now, I want to make use of num1 inside this function. So let's say I want to use num1. I say something like uint num1 copy is equal to num1. Now, this new variable I declared here, this num1 copy, it's copying the value that is in num1 into its own value. It's not referencing it. But in reference types, you cannot do this. In reference type, you only reference this variable. You can't get this as a copy and assign it to a new variable. So you see that here now I declared a new variable and I use this num1 to be the value of this new variable. So anywhere I want to use num1 copy, if I want to use num1 copy here now, it doesn't affect the initial value of this num1 I declared in line 5. So this is why they call them value types. They have like, let me go back to my slideshow. So value type stores its data directly in the memory it owns. So it stores it in its own memory. It doesn't reference it. So for every time you use a variable that is a value type, it creates a copy of the initial variable and uses it. It doesn't affect the initial variable you have declared up there. So that is that's why they are called value types. So let's continue. Variables of this type are duplicated whenever they appear in functions or assignments. A value type will maintain an independent copy of any duplicated variable. Therefore, a change in the value of a duplicated variable will not affect the original variable, which is what I said here. Let's go back to this place. Sorry, I'm trying to get the screen. All right. So which is what I said in this place. Using num1 copy here, whatever we do to num1 copy, if we say plus plus and do this, it will not affect the value of this num1 in the state level and all of that. All right. So let's look at the types of value types we have. We have the signed integers, which is the int. We have the unsigned integers, which is the uint. We have the Boolean, we have address, we have enums, we have fixed size bytes, which is the bytes 1 to byte 32. They are fixed size, so they are value types. Now, there's something I want to tell you. This thing I'm going to tell you, I don't know if you can write it down somewhere for those of you that are have your writing materials. If you look very well, you will notice that all value types are related to numbers. All value types are related to numbers. Does anyone have a question before I proceed? On this, all value types are related to numbers. Can you see my screen like this so that I won't have to take it? Hello, guys. Can anyone hear me?
Yes, we can hear you.
Come on. I think MTN is messing with me, man. All right. Can you see my screen? So sorry, let me share again. Can you see my screen? Who will be?
Good evening.
Good evening. Is that Ibu Oluwa?
Yeah, okay.
Yeah, yes. Like I told there was nobody here. That was my house.
Okay, well, yeah, please. I think Fasuli's network is very bad, so let's just be here with him to join us.
Okay. Thanks.
Please, can you guys hear me? All right, can you see my screen?
Yeah. Yeah. Now we can.
Can you see my screen?
Yeah, I can see your screen now.
Can you see the text? So I don't need to put it on slideshow.
Like the solidity value types.
Yeah, and every other text there. I just want to be sure. So I'll be able to switch between these tabs, the slideshow tabs and the remix tab. All right. Let's continue. So I was talking about Solidity data types, and we talked about the types of data types in Solidity. We have the value types and